Alright, 8th graders, lesson 52, using unit multipliers here. We use a unit multiplier such as 12 inches over 1 foot to be able to maybe change a measurement from the form that it's in, such as inches into feet and so on. And the reciprocal unit multiplier here is 1 foot over 12 inches. Now you notice that, if we multiply both of these, they're going to equal 1 over 12 over 12, which will equal 1. So unit multipliers are equal in that way. We determine which unit multiplier we're going to use based on the type of problem that we're using. So we'll see that as we move forward here. Alright, in example 1, we've got a sapling apple tree that is 64 inches tall, and they want us to convert that to feet. So we're going to convert by multiplying by a unit multiplier, and we want to end up with feet. I do it this way so that we have our label over here so we know what we're going to end up with. And here's the number we start with. We put a division bar here because our unit multiplier is going to go here. Now, which unit multiplier do I use? Do I use 12 inches over 1, or do I use 1 foot, or do I use 1 foot over 12 inches? Well, that is determined by this number up here. If we turn this into a fraction, 64 over 1, we have to learn in these types of problems that we can cancel out our units here. Not only can we cancel out numbers, but with unit multipliers we cancel out units. So because I have inches in the top over here, I want inches to be in the bottom over here. So now I look, does this have inches on the bottom, or does the second one have inches on the bottom? The second one does, so I'm going to put that up over here. So 1 foot equals 12 inches. Now I can multiply. 64 times 1 is 64. 1 times 12 is 12. I'm not done here because I have to reduce this number. So we can do 64 divided by 12. Let's see. 12 times 4 is 48. 5. When I do 5, that'll be 60 feet. I'm going to have 4 twelfths, which reduce to 5 and 1/3. Don't have enough room down here, so I'll write it up here. My final answer would be 5 1/3 feet. So 64 inches is 5 1/3 feet. Alright, example 2, a certain double feature at the theater is 270 minutes long. Like I said before, sometimes you'll have a DVD that'll say it's 180 minutes long. Well, how many hours is that? We have to learn. So we learn to figure out exactly how many hours are in a number of minutes. So let's see here. We have 270 minutes. And I'm going to multiply that by unit multiplier, and they want us to end up with hours. How many hours is that going to be? Now, what are my two possible unit multipliers here? Well, I could have 60 over a minute, 60 minutes over 1 hour, or I could have 1 hour over 60 minutes. If I go back over here to the top, draw that, we see I can cancel out my labels, so I want minutes down here, I want hours up here, so I'm going to be choosing this one, 1 hour over 60 minutes. Now in this case I can cancel out my minutes, and 270 times 1 will be 270, 1 times 60 will be 60. So now I'm going to have to do some division. 270 divided by 60. 6 times 4 is 24, so that'll be 240. Now I'll be left with 30 over 60, and I know that's a half, so I'm going to say my final answer is 4.5 hours. that's my answer for example 2. Alright, example 3 is a very interesting one here. Daniel's buying refreshments for a meeting. He wonders if 4 quarts of juice is enough for 30 students. So that's 4 quarts per or for 30 students. I can't reduce that. I could do 2. Well, I could reduce it 2 into 15, but I can't make that into a very symbolic fraction here. So it's not 2 quarts, 15 students. I still can't tell if that's enough. Sounds a little short, but maybe it's enough. Well, what we're going to have to do here is convert our quarts. We're going to take this down here. We're going to go ahead and say I've got 4 quarts. I need to multiply it by a unit multiplier, and now I want to end up by ounces. Okay, I know there's 32 ounces and 1 quart. So now I can multiply 32 times 4, 8. So 128 over 1 ounce, so 128 ounces. Now I've got 30 students that has to be split up between. So over here I'll do 128 divided by 30. Let's see, 3 times 4 will be 120. I'll be left with 8 over 30. So I'm just going to round here because that's what the problem is asking me. So that means each student's going to be about 4 ounces. Well, that's, how much is 4 ounces? Well, that's about half a cup, half a glass. Most students could drink a full glass of juice. So if this is right here, this is only a half a glass. I want a full glass, so I'm gonna have to do half plus a half, or half time. I'm gonna have to double. So I'm gonna go back over here, and the question asks, if not, suggest a more reasonable quantity. A more reasonable quantity in my book wouldn't be 4 quarts, it would be 8 quarts. So that would be my suggestion. So I would say, no, this is not a reasonable amount as part of my answer. And then when asked how many do I need, I'm going to double it. I'm going to say 8 quarts is what's going to be necessary here. Alright, example 4 here. Samantha drove 100 miles in an hour and 45 minutes. How many hours did it take Samantha to drive 100 miles? Well, 45 minutes out of an hour is going to be 45 over 6. And we reduce that to 3/4, and hopefully that's 0.75. So we could say that Samantha drove for 1 hour and then 3/4 of an hour, or we could just say 1.75 hours. Either way, that's going to work out. We've just dealt with the minutes over here. We assumed that we would keep the hour. The hour, we just had to figure out what fraction was the minutes. Now, that's very simple, very easy one. Very obvious, I think, to most of you, but yet it's just good to go over it. Alright, example 5, we've got Noel ran 1 mile in 7 minutes 30 seconds. Find his time in minutes. They don't want the seconds there. So sometimes Racer will express things as I ran a 7.5 or a 7.5. Usually that has to do with seconds. So in this case they want minutes, so maybe it's a long distance runner. So we take our minutes. There's 30 minutes that Noel ran in. We know the 7 minutes, so we're going to put that over here. We just want to deal with the minutes. And there's a total of 60 seconds in a minute. So we've got 30 seconds up here, 60 seconds down here. That converts to 1/2. So if I add 7 plus a half, I can say he ran in 7.5 minutes, or I would also accept 7.5 minutes. So again, what you see here is that we've got a label. We just want one type of label. We didn't want 7 minutes and 30 seconds. We just want minutes. So we convert that. Alright, in our last example, example 6 here, we're dealing with carpeting. Now, when the day comes that maybe you have to go to the store and buy some carpeting for a house or an apartment, carpeting is usually sold in yards. And in this problem we have feet. He's got a room that is 13 feet 6 inches long, and he wants to know how many yards that is. So I've got 13 feet 6 inches, so 13 and 6 out of 12, which is 13.5 feet. So now you can see in this example here what we were doing in the past example. I say, well, is that really necessary? Well, it helps us out here if we can get to a decimal number. Okay. Now I can go ahead and start with 13.5 feet, and I want to convert that to yards. So this will be over 1, so I want to end up with yards. And I know I've got feet up over here, so feet have to go down over here. So yards will be up here. And 1 yard equals 3 feet. So this will cancel those out, and I'm left with yards. So I'll get 13.5 over 3. And I have to do a little division over here. 13.5 divided by 3. We'll go into there. Let's see, 4 times, that'll be 12. Carry down the 5. That'll go in there 5. And I need my decimal. So once I add the label up there, then I can say my answer here is 4.5 or 4.5 yards. So we took this measurement up here and we ended up with that measurement down there, because in the carpeting world they work in yards, square yards. They do not really work in square feet because they're usually carpeting large rooms. So we need to be able to know how to convert from feet to yards. That's it for today. You can get started on the practice set and your lesson.